Hi, and welcome to part 2 of the series on solving single-step equations. In the last video, we watched equations that needed adding or subtracting to isolate the variable. That the variable had something subtracted from it, and then you needed to add that to both sides to get the variable alone, or you had the variable had something added to it and you need to subtract from both sides. There are other ways variables can be connected to numbers. Other operations could be performed on them. Let's take this example. 9x equals 18. And when your instructions are solve, that means you want to find what number does x need to be to make this true. In some different kinds of equations, there's more than one answer, but in this equation, there's one answer. So a lot of you are going, oh, I know 9 times 2 is 18, so x must be 2. Well, that's wonderful when they're easy numbers, but we need to have a process by which to do this. And I'm interested in developing your process, and I'm going to ask you to show work. So you know that 9 times x is 18. You want 9 times something to be 18. You want to know what the something has to be. Well, what's done to the x? You have to look. Okay, I'm going to work on the left side because that's where my variable is. And I have 9 times x. That's what you say to yourself. Well, how do you undo multiplication? And I'm getting better at writing with this. Sorry, you're just going to have to be patient. How do we undo that? What's the opposite of multiplication? Well, we divide. So if I have 9 times x, remember when we write the 9 right next to the x, it means they're multiplied. It's the default operation, equals 18. If I divide both sides by 9, now a fraction, that means divide. I have 9 times something and divide by 9. You multiply by 9, then divide by 9. You do something, then you undo it. 9 divided by 9 would reduce to a 1, no matter what x was, so you want to make a 1 in front of the x. But I can't just say now x is 18. That's not true. If I decide I need to divide the left by 9, I have to divide the right by 9 also. So 9 over 9 gives me 1x, and we don't generally write the 1 in front, and that's equal to 2. To check my work, I would check to see what is 9 times 2 equal to, and it is equal to 18, so that checks. So when the first thing you have to do to solve an equation is decide which side do you need to look at. You need to look at the side that has the letter. The next thing you have to do is decide how the numbers are connected to the letter. In this case, they're connected by multiplication, so subtracting 9 isn't going to help. You have to undo the multiplication. If I had 9 plus x equals 18, students often get this confused. That's why I'm doing this. It means I have 9 more than x over here. I want to make it just x, so I'm going to subtract 9. Those two are different problems. You have to make observations about the problem you're solving before you can solve it. So here you have to observe that you are multiplying by 9. You don't undo multiplication with subtraction. You undo it with division. And over here you have to see you're adding 9. You don't undo adding with division. You undo it with subtraction. Okay, so let's try another example. All right, so let's try this one. 15 equals 5n. N is our variable here. X doesn't always have to be our variable. I don't want to fall into that trap for you. So what I see here is I have to work on the right side of the equation because that's where my variable is. I don't divide by 15 just because it's on the left. No, I have to look and decide which side do I need to look at to make my process from. The side with the variable is the side you work with. So I have 5 times n. So I need to undo multiplication by 5 by dividing by 5. So I divide this side by 5, and that will give me n by itself. But I also have to divide this side by 5, and this is how you show your work. I do not want to see just an answer. I want to see this work. Okay, so 3 equals n. And again, that's different. If I had 5 plus n, I wouldn't have divided. You have to look and see how the letters are connected. You can't just say, oh, it looks like that problem I just did, and decide you're going to subtract again. You have to work very carefully here. So that's a kind of a pet peeve of mine. Students solve a different problem than I give them. So let's try another one over here. We'll keep that one up. What if I had 36 equals 9a. So 36 equals 9 times a. You stop the video and try this one. I believe you have the ability to stop it and then come back and I'll show you the answer. All right, I'm going to trust you. You're back. I trust you stopped it. So I look at the left side. There's no variable. The letter's over here. So I work with this side. Divide by 9. 9 times a is what I have, and I want a by itself. So I divide by 9, so that makes that number. So I just have 1a. And I have to divide by 9 over here because I have to keep the balance. I decide what to do based on this side, but I also have to do whatever I decide, the same exact thing to that side. I decided to divide by 9, so I have to divide by 9 over here. 36 divided by 9 equals 4. All right, we'll try another one, and then we'll move on to division. So, what about 15x equals 105. All right, this one is harder to guess at, right? So this is why we need a process. Stop the video and try this one. Use your calculator if you need. So I look at this problem and I see that the left side has the x. It has the variable. So I have to look at what's done to the left side. How is the x connected to the 15? 15 times x. So to disconnect multiplication, you have to divide. So I divide that side by 15, and then because I did that, I have to divide this side by 15. 105 divided by 15 is 7, and I get x equals 7. The way I would check my work would be I go back to the original problem, see if 15 times 7 comes out to 105. And it does, so that checks. All right, let's try a little different problem. What if I had x divided by 3 equals 5? Everybody looks at this and gets all concerned because it's a fraction. It is division, okay? Now you could also think of this problem as 1/3 times x equals 5, and then you could divide both sides by 1/3, okay? And remember, but nobody's a fan of dividing fractions. You get 15 when you do that. You could do it that way. So you could turn that division problem into multiplication, but there's an easier way to do it. You have x divided by 3 equals 5. And you're solving for x. I'm dividing by 3. First of all, I'm working on the left because the x is on the left. I can ignore the right for a moment. The left is going to tell me what to do. X divided by 3 is undone by multiplying by 3. If I multiply the left by 3, I have to multiply the right by 3. And here's a rule. Anytime you multiply a fraction times its denominator, you're left with just the top of the original fraction. So I had x divided by 3. The denominator was 3. I multiplied it by 3. That leaves me with x. This crosses off and becomes a 1. Just as if I had 3x and I was dividing by 3. 4. 15. So I decided to multiply by 3 because this is x divided by 3. Say those words in your head if it helps, and then say to yourself, how do I undo division? I multiply. So I'm going to multiply by the bottom, and then I get, once I decide to do that on this side, I must do it on this side. So I decide to multiply by 3 to get x alone, so I must also multiply by 3 here. Let's try another one. A divided by 4 equals 6. Now you try this one. Stop the video and try it. Okay, so I have a divided by 4, and it doesn't matter. I can multiply in front or afterwards. 4 times a over 4. It's just going to leave me with a, but because I multiplied by 4 there, I have to multiply by 4 here, and I get a equals 24. Let's try one trickier one and see how you do, because it can be done one step or two. What if I have 2/3 times x equals 6? So I could do so I have 2/3 times x. I could divide both sides by 2/3. And when I write this, students go, oh, it's complicated. Well, something divided by itself is still going to give you a 1. I have to divide the 6 by 2/3. So this becomes a 1 for 1x. To divide a fraction, I do 6 divided by a fraction will be 6 times the reciprocal of the fraction, or you can do 6 divided by 2/3 in your calculator like you've been taught. And that gives you 18 over 2, which is 9. The other way you could do this one is in 2 steps. don't like the fraction, we're going to do something called clearing the fractions. We're going to multiply 2/3 by 3. And what that will do, it will just leave us with this. 2/3 times 3 makes that happen. But if I multiply that by 3, I have to multiply this by 3. So then what I'm left with is not the answer, but it's a new problem. And it's a problem that looks a little easier. 2 times x equals 18. 2x divided by 2 is x, so I have to divide both sides by 2, and I get x equals 9. All right, that's video 2 for solving single-step equations. Hopefully this helps you get through the homework problems and the other assignments associated with this, but more importantly, I hope it helps you understand. Email me if you need help. Thank you.